Now we will see how IEC 61499 is used to model distributed systems. So the artifact for describing devices of the automation world is called the device in 61499 architecture. And a device is a model of a functional unit like a PLC or embedded microcontroller or a CNC or a motion controller and so on and so forth, that is capable to interact with the environment, with a process, and with all other information in the automation system. So device as an abstract model is composed of several parts. First of all, it is an interface. The device has interface to the process. That is a controlled process, and also it has interface to other such devices. That's called communication interface. So the interfaces are implemented as libraries of service interface function blocks. In the device, there could be one or more resources, or even there could be device without any resource. Examples of devices could be, for example, micro PLC or nano PLC ICE block, as it's shown here on the left-hand side. That's a wireless nano PLC developed via FlexBridge. Or it could be even a soft PLC that is running on a computer. So here is a screenshot of a soft PLC created by NXT Studio. Soft PLC is a computer program that emulates behavior of a real controller. The standard defines three classes of devices, from the simplest class 0 to the most complicated and sophisticated class 2. So class 0 device is capable of hosting function block network that is programmed firmly and cannot be changed during the device lifetime, but connections between function blocks can be created or deleted from the engineering tool. So this class of devices intended to be applied to very basic resource constrained devices where it cannot be imagined to transmit new device to new function block instances or function block types, but still that could be fully functional control device that is capable of starting and stopping application, changing function block network by changing connection between function blocks. And it also could, device class 0 can provide to the engineering tool description of what are function block instances that located inside the device. And the device class 1, it has much more extended functionality because it can create new function block instances and connections between them. It can start and stop application, can delete function block instances and connections, and can answer queries about data types, function blocks, and connections. So device class 1 can create new function block instances from the library that is stored in the device, but it cannot change this library during its lifetime. So engineering tool cannot send new function block types to update this library. And finally, class 2 has all imaginable functionality. It's a fully reprogrammable, can create new function block types. So in addition to all what device class 1 can do, device class 2 has this extended functionality. Same as function block types and sub-application types, device types are instantiated. So But interface of the device may have only data inputs, and device cannot have any outputs. The parameters of the device are used to tell, for example, how this device can be identified and contacted. For example, in NXT remote device type, there are 3 parameters, one of which is watch ID, is used for transmitting the debugging data to the engineering tool. And the manager ID is used for communicating with the device by the management protocol defined in IEC 61499. As said, a device can contain 0 or more resource instances, and resource is a kind of virtual box where function blocks are executed. So it's an execution container independent from other resources. So function of the resource is to accept data and events from the interfaces that provided by the device, process data and events, and return data and events to the interfaces. So resource has some scheduler for executing function block networks that are allocated to that resource. So it has a means of execution control that implement the execution control function of the function block. And the scheduling function that decides which algorithm will be scheduled for execution at which time. So the scheduling function of a resource actually schedules algorithms for execution as it was described in the behavior of a basic function block. So it also determines sequence of execution of function blocks, as it could be several events coming to a single function block input, and then the resource decides which of these events or which of the function block instances has to be taken for execution. In some of the resource types, these events are queued in the first in, first out queue. In other implementations, there could be cyclic routine for selecting next function block for execution. Resources again are instantiated in the engineering tool when you define a device. When you instantiate a device type inside the device instance, you can either see already predefined resource types that are part of the device type definition, or you can add new resource instances of some available resource types. So device management. IEC 61499 defines a XML-based open protocol to be used to configure the various devices, for example, for sending new function block applications or particular function block instances, or starting and stopping these function blocks, and creating and deleting connections between function blocks. So for this purpose, usually a special resource type, management resource, is created inside the device type, and that resource type is responsible for communication with the engineering tool and supporting the device management protocol. So here is an example of how device manager communicates with the device in order to create this function block application, small function block application consisting of 3 function blocks that are connected with several event and data lines. So you can see that the set of management commands executed one by one. Engineering tool first creates a function block with a name diag of a type sub L, also this function block. Then it creates function block log with of the type dialog, and then it starts creating connections between these blocks. So these commands are sent from the engineering tool side to the management resource of the device, and inside the management resource there is a function block device manager that is connected to communication interface and receives these commands and interprets the commands, creating the corresponding function blocks and connection between them. So by default, device contains the resource manager. In this manager resource, it contains FB kernel of type device management kernel that executes management commands and performs all the actions related to the device management. So the distributed system of in IEC 61499 is a highest level entity in the hierarchy of 61499 artifacts. So it's describing, capable of describing heterogeneous automation system that consists of several devices connected with several communication interfaces, and the functionality in the form of applications which are mapped to the devices. So system configuration is this structure defined in IEC 61499, and it represents physical deployment of the design, of the functional design. So the system configuration consists of devices, applications that are mapped onto devices, and communication network that connects devices with each other. So applications can be, each of the applications can be running in several devices. So an application that is a network of function blocks connected with event data flow is said to be mapped to particular devices. So in a single function block application, its function blocks can be actually executed in completely different devices, and these communication lines connecting in the abstract application, connecting function blocks with each other with event and data flows, they will be by means of the engineering tool converted into communication code that will enable the data to travel across interfaces, communication networks between the devices. So this process of mapping can be seen as follows. Imagine that we have an application that consists of 3 function blocks. And we want to map this application onto 2 devices. As you can see, some of the communication lines, connection lines of data connectors and event connectors that are connecting, for example, FB2 with FB3, they are crossing device boundaries. So in these places, the engineering tool will insert the corresponding communication tool. So, and that could be done completely automatically. So as a result, the blocks FB1 and FB2 will be dropped into one device, and block FB3 will be in another device. And this communication code can be seen as also communication function blocks, such as publish and subscribe blocks, that will, in a seamless way, implement connection and data flow and an event flow between these 2 devices. So the application developer wouldn't need to think about manual insertion of any communication code, and majority of modern tools perform this operation in the background.